So what's next? So we have a minimum fee that people need to pay. Let's also now keep track of all these users in here. So we're probably going to want to store them in some type of data structure. Now, here's a great question. What data structure do you think we should use? We need a way to keep track of everyone who entered the lottery, right? So that when we pick a random winner, we can choose from all the people who have entered. So what should we use? Should we use a whole bunch of address variables? Should we use an array? Should we use a mapping? Pause for a second and type into the chat what you think we should use. I'm going to go ahead and use an array, a dynamic array, an array that will grow in size. And the reason for this will become more apparent, especially when we get to picking a winner. But the most important thing is that, as we know, mappings can't be looped through. So if we're looking to pick one random person, how are we going to choose the random person using a mapping? I don't know. If you can figure that out, it's phenomenal, and you should win a Nobel Prize or something. But we're going to use a mapping for this. And this is going to be a state variable. So we're going to want to put it with our other state variable right here, right underneath this. So we're going to do, this is going to be an address array, because it's going to be an array of players. We'll call it private, and we're going to do s_players. Since this is going to change, the number of players in this array is going to keep changing. This is going to be a storage variable and not an immutable variable. But I'm going to add one more thing to here as well. Since we're going to need to pay these players some ETH, this is going to be an address payable. So we know we can actually pay all these players once they enter the lottery. So we have our array. And now when somebody enters the lottery, we can just say splayers dot push, and we'll push the payable message.sender. Remember, we need this payable keyword to make an address allowed to get ETH or whatever native token. So we're going to go ahead and push them onto our array. Awesome. So this looks pretty good. And our function's almost done here, but it's missing a couple of things. And one of the main things is actually an event. As a rule of thumb, whenever we make a storage update, we should emit an event, which is this new place that we haven't really spoken about. We have a couple of videos that we're going to go ahead and watch now to explain what events are and why we even use them. But the two main reasons for events is they make migrating or updating your contracts easier, and then it makes front-end indexing or storing data about contracts much easier as well. Since we're not doing too much on front-end in this course, the second one might be a little obscure to you for now, but for those of you interested, we're working on a new full stack course, so be sure to stay tuned for that. But let's go ahead and let's watch this video that I previously recorded about events. Now I have two videos on this. One is on my channel, one is on the Chainlink Labs YouTube channel. The one on the Chainlink Labs uses Hardhat, the one on my channel uses Brownie. Let's watch just the part about setting these up and working with these. And we won't actually watch the Brownie or the Hardhat parts because we're going to be working with events in Foundry ourselves.
Now, if you've worked with Solidity, you've probably seen these things called events before. Or maybe you haven't seen something like events, but you've always wondered how Chainlink or the Graph or some of these other off-chain protocols work under the hood. Or maybe you just love watching these VODs. In any case, in this video, we're going to learn all about logging and events in Solidity, how to view them on Etherscan, and we'll work with them in Brownie as well. Now, if you like Hardhat, once again, I also have a Hardhat version of the code that we're going to go over, and I've got a Hardhat blog as well. Links are in the description. All right, let's get froggy. Now, it's the Ethereum virtual machine, or EVM, that makes a lot of these blockchains tick, like Ethereum. And the EVM has this functionality called a logging functionality. When things happen on a blockchain, the EVM writes these things to a specific data structure called its log. We can actually read these logs from our blockchain nodes that we run. In fact, if you run a node or you connect to a node, you can make a getLogs call to get the logs. Good function naming design. GetLogs gets the logs. Now, inside these logs is an important piece of logging called events. And this is the main piece that we're going to be talking about today. Events allow you to print information to this logging structure in a way that's more gas efficient than actually saving it to something like a storage variable. These events and logs live in this special data structure that isn't accessible to smart contracts. That's why it's cheaper, because smart contracts can't access them. So that's the trade-off here. We can still print some information that's important to us without having to save it in a storage variable, which is going to take up much more gas. Each one of these events is tied to the smart contract or account address that emitted this event in these transactions. Listening for these events is incredibly helpful. Let's say, for example, you want to do something every time somebody calls a transfer function. Instead of always reading all the variables and looking for some to flip and switch, all you have to do is say, listen for event. Listen for that event to be emitted instead of writing some weird custom logic to see if the parameters changed at the certain time and doing some weird stuff like that. Listen for these events. So a transaction happened, an event is emitted, and we can listen for these events. This is how a lot of off-chain infrastructure works. When you're on a website and that website reloads when a transaction completes, it actually was listening for that transaction to finish, listening for that event to be emitted so that it could reload or it could do something else. It's incredibly important for front ends. It's also incredibly important for things like Chainlink and the graph. Chainlink, for example, in the Chainlink network, a Chainlink node is actually listening for request data events for it to get a random number, make an API call, or etc. Sometimes there are way too many events and you need to index them in a way that makes sense so that you can query all these events that happen at a later date. The graph listens for these events and stores them in the graph so that they're easy to query later on. So events are incredibly powerful and they have a wide range of uses. They're also good for testing and some other stuff, but you get the picture. They're really sick. Now that we know what events are, let's look at what they look like, how we can use them, and how we might use them in our smart contract development suite. Now, here's what an event is going to look like. We have an event here called stored number. So we have basically a new type of event called stored number. We're saying, hey, Solidity, hey, smart contract, we have this new event thing. We're going to be emitting things of typed stored number in the future. When we emit this event, it's going to have these 4 parameters. It's going to have a uint256 called old number, a uint256 called new number, a uint256 called added number, and an address called sender. Now, for the astute people here, you might have noticed that there is another keyword in here, the indexed keyword, and this is a really important keyword. When we emit one of these events, there are 2 kinds of parameters. There are the indexed parameters and the non-indexed parameters. You can have up to 3 indexed parameters, and they're also known as topics. So if you see a topic, you know that that's going to be an indexed parameter. Indexed parameters are parameters that are much easier to search for and much easier to query than the non-indexed parameters. In fact, way back in that getLogs function, it even has a parameter allowing us to search for specific topics. So it's much more searchable than the non-indexed ones. The non-indexed ones are harder to search because they get ABI encoded and you have to know the ABI in order to decode them. If that confused you, don't worry about it. We're going to explain it. Isn't this video great? Now, this just told our smart contract that there is a new type of stored number, a new kind of event here. We need to actually emit that event in order to store that data into the logging data structure of the EVM. To do that, we need to do something that looks like this. This is what it looks like when we emit an event. It looks very similar to calling a function. So you call emit and then the name of the event, and then you add all the parameters in there that you like. Here's the full example of a smart contract that has an event and is going to be the example that we're going to walk through in Brownie. Again, if you want to see a hard hat edition of this, link in the description for the hard hat edition, both of this video and the blog. Now, in this smart contract, whenever anybody calls the store function, we're going to emit this event. Here's an example of a transaction where we called the store function with a value of 1. Let's look into the logs to see what this event actually is going to look like. An event is going to be broken down like so. The address of the contract or account the event is emitted from. The topics are the index parameters of the event. Data. This is the ABI encoded non-index parameters of the event. What does this mean? This means that we took those parameters that were non-indexed, we matched them together with their ABI or application binary interface, pumped them through an encoding algorithm, and boom, this is what we got. If you have the ABI, they're very easy to decode. If you don't have the ABI, they are very hard to decode. These non-indexed parameters cost less gas to pump into the logs and are harder to query, like we said. So if you think something's important, but like not that important, you dump it in data. You dump it into non-indexed. Now, in this particular contract, since we have verified the code, we verified the contract, Etherscan knows what the ABI is, and we can view this in dec or decoded mode. Hex mode is obviously the non-decoded mode, or in its raw hex or hexadecimal or encoded mode. You can read more about the layout of these events in the Solidity docs.
Okay, great. So now that we've learned a little bit more about events, we can go ahead and start using them in our project. Remember, just as a rule of thumb, anytime we update storage, we want to emit one of these events. Like I said, the use case for these right now might not be crystal clear, but as you get deeper into the space, it'll start to become more clear why events are so important. So for us, we're going to go ahead and create our own event. And if we scroll up to the top, we can even view our layout and see where our events should go. Okay, imports, errors, contracts, types, state variables, events. Okay, great. So this is going to come after our state variables, but before our functions. So I'm even going to make it look nice. I'm going to say events like this. We'll create a new event. And I like to do verb-based events. So we would do raffle entered or entered raffle, and we would put the parameters in here. We do address indexed player like this. So now that we have this entered raffle event, we can go ahead and do emit, raffled enter, or entered raffle, message.sender, like so. And awesome, our enter raffle function is just about done. We're gonna update it pretty soon with something else, but this is pretty good.